Okay, now we're going to write it in a different format. D dx. Okay, these two things, they go together. The d dx and then the grouping symbols. That means take the derivative of whatever I put inside the parentheses. So the rule is the same, it's just a different format. The power comes down, the exponent decreases by 1. That's it, right? This makes me think of derivatives and the hierarchy. This is also the derivative. It's just in a different format. D dx means find the slope of this thing, right? Change in y over change in x. Now we're going to go the other direction. Antiderivative means integral. Okay, so last class we learned what an antiderivative was. The last unit we learned what an integral was. They're connected. Okay? So we're going to write down the integration formula with two formats. Integration, right? You typically start at the derivative. So if the derivative is a power, okay, f prime to f, that is this direction. That means I need to do an antiderivative to move that direction. I increase, right? We're going up. So I'm increasing the power. And then I'm dividing by that same number. I like to write it in front so that I can really see that coefficient. So far, that's stuff that we've already talked about. Here's the one new statement. Integral, parentheses, dx. This is the new notation. Now, we saw this last unit, but I had numbers. There's no numbers today. The integral symbol means do the antiderivative. That's what it means. Algebraically, do the antiderivative. Same rule, different notation, different vocab word. Okay. It's about 1/3 and 2/3 split here. And we're going to get maybe 3 rows. Okay. Integral f of x dx. Now I'm going to bold part of this. The integral and the dx go together. Like, you can't have one without the other. Those are the bookends. The part in the middle, that's the part you're actually doing the antiderivative of. This is called the integrand. When you have radicals, the thing under the radical is called the radicand. When you have an integral, the thing inside the integral is called the integrand. It's just a vocab word to tell you the piece of this that I'm talking about. Right? That part is called the integrand. Okay, equals. Okay, so We're looking at our hierarchy. Notice here, I'm at f of x. And the integral says go backwards. So the answer is capital F of x. And I'm going to write plus c. It could be a k. I'm just calling it a c today for a constant. But notice the integral means go up the hierarchy. And so we're going to write the statement again, but I'm going to pick a different place in the hierarchy to start. And I'm just going to bold the part that comes together as a reminder, like that's the start and that's the end of the statement. And I'm just going to kind of highlight my integrand. And then I'm going to use my function hierarchy. I start at f prime, I go backwards for the integral, and I get f of x. It's just like the general solution we used last class. That's why there's the plus c here. And we'll write it one more time for good measure. Start at the second derivative. And I'll just bold this. Notice I didn't put extra parentheses here. You don't really need them. That's why the start and the stop of the integral is a little S shape and then the dx. Okay. The indefinite integral has no bounds, no start, and no stop point. When we first looked at the integrals, we looked at it as the area under the curve. There is no area because there is no specific spot on the graph I'm talking about. This is a general statement. I don't know where that graph is. That's where the plus c comes in. Always, right? No bounds, no start, no stop. Always use the plus c. You have to use the constant. It's the general solution here. There are no numbers to tell you where to put it. All right. Let's actually do a problem. Integral of 7 dx. That means find the antiderivative. 7x, yes, plus c or k. It does not matter the letter, just a letter. K, kind of like for constant. C, also like for constant. That's it. That's the answer. Notice that little sheet I gave you? I gave you all the answers. So as we find them, we can mark them off and write down the letter. It's a lot easier for me to check your work if you've matched it to the letter. So let's find 7x plus k and just put a little n in your box. Yeah. I did go up. What? Look at my power. Look at my power. The variable power went up because this was 7x to the 0. And so I did go up in power. 7x to the first over 1.
No, but I thought the integral one was supposed to go down in power.
Nope, nope, nope. Integral goes up. Integral goes up. Integral is antiderivative, so it goes up in power. All right, let's do number 2. X to the 5th. Antiderivative. Go up in power. 6. Divide by the same number. Plus c. And then I'm going to scan for the letter. How could I check if you did the questions? I could just ask you to be like, number 6, what letter?
R.
R? Is it R? We'll find out. Okay, well, number 2 is G, okay? So as you're doing the problems, look for your answers and record the letters. That way I can quickly check the questions you've done. Okay? So I'm scratching it off. Let's go ahead and do number 5, and I'm going to let you work for a little bit. Up in power, divide same number. Oh, there's more than one piece. Just do more than one piece. Exponent x plus c or k. And then look, so we get 1, I'm going to scan for the first term, 1/4 x to the 4th. O? No. L? L, there it is, L. Okay. They are only used once, so scratch them out as you use them. The sheet you picked up here? No? I'll grab it. All right, let's go ahead and flip over to question 10. I'll do a few and then give you a little bit more time to work. So we're going to start, we're going to do 3 questions. We're going to do 10, 11, and 13. Okay, so notice that this is not the power format. It has to look like the power format before you can do the antiderivatives. Has to. Otherwise the rule doesn't work. And so before you begin, you have to take this and convert it to the power format. So the 2 exponent becomes negative when I move it up to the top. Okay, notice I have not done the rule yet. That's above the line. Now I do the antiderivative. Add 1, divide by the same number. Rewrite with no negative exponents. Plus C. Scan for letter M. Cross off. Now I look at number 11, I'm like, okay, I still need this to be in the power format. I just happen to have 2 pieces and some coefficients. Well, the 4 doesn't move, but the x cubed does. Minus, okay. The 5 doesn't move, but the x to the 4th does. Now I do the antiderivative after I get it in power format. Okay. Careful, adding 1, divide by same number. Adding 1, divide by same number. The small things is where you're likely to make a mistake, like in my reducing. Negative, negative is really plus. As I reduced, I also moved my variable back to the denominator because it still had a negative exponent. Now, when you're looking for your answers, sometimes I wrote the coefficient in front, sometimes I wrote them together. So you're going to have to be a little bit flexible in how you find that match. Q. All right, let's do 13. Oh, okay. Radical. Power over root. I have to write it in the power format first. 2 x power 1 root 3. Power 1 root 4. Now do the antiderivative. Okay. You've got a calculator, right? Do your arithmetic. Don't get it wrong. Add 1. 4/3. Divide by 4/3. Multiply by 3/4. That's why I like to say multiply by reciprocal. Helps me get that fraction right. And where does that go? So 3/2 x to the 4/3. Now, just in case, I'm scanning my answer. I know that I haven't done the second half yet. I see a couple fraction exponents, but I don't see a 4/3. Oh, maybe you have to put it back into a radical. Yeah. Okay, so first I added 1 to the exponent. Okay? Now, the rule says I'm coming. Okay, here we go. I'll just do it again over here. So I keep the 2. I'm going to add 1 to the exponent. And I would divide by the same number. But I don't actually want to divide by a fraction. So instead of dividing by a fraction, I multiply by the reciprocal. Does that make sense from here to here? Okay. 6/4. And so I just reduced it. Okay. You might have to power root, cube root, x to the 4th. All right, let's see. Can I find it? Cube root, x to the 4th. There it is. It looks like h. It looks like it's going to be h. Let's go ahead and do the second part. Yes, Sean.
I don't want to be spelling that.
That would be my mistake. There should be. Okay. 4. Let's do it. Add 1. Multiply by reciprocal. So instead of saying divide, it's easier to say multiply by reciprocal. Minus 16/5. Power root. 16/5. Root x to the 5th. And it does match h. All right, here we go. Let's flip it, and let's do a few of them over here. Here, we're going to look at 16. Guys, there is no product rule for antiderivatives. The only rule I gave you is the power rule, which means you have to make this look like a power rule. ... Like a polynomial, it has to look like that first. Which means if you've got a square out here, you have to actually do the multiplication first. Okay, so integral 4x squared minus 12x plus 9. Right, all I did is rewrite it into power format. Now I can do the antiderivative. Add the degree and divide. Add the degree and divide. Plus, 9x plus c. Okay, and I scan and I look. Or K, C or K. 9999. Yep, thank you. B. Okay. But the denominator, a little bit tricky. There is no quotient rule. There is no quotient rule, which means you have to make it look like this polynomial first. Now it doesn't matter if my exponents are fractions or negatives, that's okay. Notice your divide bar is over all of this. And so I'm going to write it like this. You should be like, okay, that makes sense, right? The whole thing was divided by x to the fourth, which is the same thing as multiplying by the reciprocal. But instead of writing it like this, I'm going to write it like this, x to the negative fourth. The only reason I get to keep those grouping symbols is because that divide was for all of those three pieces in the numerator because of how long that division bar was. And now I'm going to distribute. Right now I'm going to do the multiplication. X to the negative 2, 3x negative 3, now I'm ready for the antiderivative. Add exponents. Okay, so add, divide, add, divide, add, divide. Okay, I'm like, I got it. But with all those negative exponents, you just be really careful how you rewrite it. Rewrite it with no negatives. Now in this particular case, instead of writing the coefficient in front, I'm putting the variable with the denominator because that's where it was. Minus happens to be C. Notice that once I do the antiderivative, that those symbols that we talked about, they disappear. Right? Once you do the antiderivative, the symbols are gone. B and C. Okay. 18? Both tricks. Multiply and distribute the negative exponent. 2x, 3x plus 2, and I'm going to say x to the negative 1/2. The only reason you get to keep those grouping symbols, look at that divide bar. It's under both of those numerator pieces. That's why they're all still connected. When I have three things together, just pick two at a time and do them. Okay, and continue. Another way to match your answers, look at how many terms you have. I only have 2 terms there, so you're looking for something with 2 terms and a plus C. Helps narrow your eyes a little bit because there's so many choices. All right, leave a little placeholder. Add 1, reciprocal. Add 1, reciprocal. Okay, so The power stays, the root moves. Oh. Here. Yes, but 21 first. When I look to rewrite this, super careful. That's times 1/2 x negative 3. The 2 does not move. It's still divide by 2 and times by this. So when you distribute, you end up with 1/2 x 0, 2x negative 2, minus 1/2. Now x to the 0 it's really just nothing. 1, yeah. Okay, so careful with that 2 in the denominator. It doesn't actually go anywhere.